Good afternoon, participants and distinguished panelists. After a high octane deliberations and context setting by Kaushik Madhavan, followed by Subraman Patil, and also uh, deliberations by other speakers, I'm here to just conduct another panel discussion which is on rethinking vehicle architecture for SDV era. Since it was, as I mentioned, high octane, I just want to take it little light in setting the context so that now we have some sort of a unwind and rewind from the strong deliberations that we had. So let me start with a simple question. I just want to ask everybody, including the panelists, a simple question. How many of you would like to grow younger in spirits without diet, exercise, or workouts, or plastic surgery? Nobody? Yes, Rashmi is one. Nobody is interested to grow younger? Are you sure? You don't want to grow young? No, I'm asking you. You are intent. I don't know whether there's a way, but anybody? Okay. I could see a few, but others would like to probably grow like me with the gray hairs and get into the other side of the life. Okay, so imagine cars do that exactly the same, become better with the age. That's the promise software-defined vehicle gives. You buy a vehicle today, and instead of gradually becoming outdated, it stays young, keeps improving through updates, and that add new safety features, boost efficiency, and even unlock a lot of options from the user experience point of view and entertainment. In short, SDVs flip the traditional story of car ownership. As we buy, it's not going to be the same; it will go younger. So they transform vehicles from being static machines into dynamic, evolving platforms. And that exactly is what we are going to discuss today. The opportunities, the challenges, and the road ahead for this new era of mobility. That's the topic, rethinking vehicle architecture for an SDV era. SDVs, can we call SDVs the equivalent of Markandeya or Elijah from the Christian belief or Idris from Islamic belief, who were given eternal life by their respective religions? Yes, Markandeya, there is no death, he is eternal. So SDVs are, we can say that it's equivalent of these three people. Anyhow, cars have always been hardware-driven machines. But software was just a support system. But today it's the reverse is happening. A CEO of a leading OEM at the recently concluded IAA show in Munich said that cars, when the powertrain was gaining momentum, OEMs in the West, especially US, they said, we are selling engine and car comes free. So today, it is going to be a different story with SDVs. The OEMs started selling or started thinking about selling that we are selling software and car comes free. So that is the uniqueness and speciality of software. Of course, you're all technocrats. I'm not a technocrat. I'm just giving a little story so that we can unwind and then think fresh. So for why it is very important? Why should the SDVs are important in the trajectory? See, for automakers, SDVs shorten the time to market. Instead of perfecting every function before the launch, they can actually continue to evolve, and companies can update features later. They also open up new revenue streams, like our panelists, one of the panelists and one of the speakers said. However, there are a lot of challenges turning cars into a smartphone on wheels. Some of them are like data overload. Like for example, millions and millions of data will be no, terabytes of data will be uploaded. And then cybersecurity risk that my past speaker touched upon. And there are talent gaps, how to manage. That's an important, even Kaushik mentioned about it. The talent gap, we need a very hybrid variety of talent to support this. And cost of development. However, we are seeing vehicle architecture moving from centralized to zonal architecture, followed by domain-based architecture. These are certain things that are evolving, and vehicles are also transitioning from legacy ECU to HPC platforms, and many developers are resorting even of quantum computing. Future cars will generate enormous data, as I mentioned earlier, requiring powerful onboard processors. Therefore, architecture should be supported by effective middleware. And SDV developments require billions in investments. That's why partnership is essential. Besides, there are business model confusion. For instance, will customer pay monthly subscription for the features in the car that they already bought? So these are certain challenges that I have noted down, and we have a panel of experts to explain us about the various topics around SDVs. Let's hear from them. Lady first, Rashmi, I would like to ask you about the set of challenges faced by tier 1s and OEMs in transition from legacy ECUs to HPC platforms.
Can you hear me all right? Okay. Thanks, Murli. I'll definitely take you up on that growing younger without gymming, right? I mean, that could be a dream come true. Well, I may not be getting any younger, but definitely there's a promise for our cars, to sort of outlive the 10, 15 years that you and I have been used to, as owners of the car. So probably they're going to get more exciting with the times, as Murli very nicely introduced the topic. Now, coming to the question about challenges. I mean, I think a lot of them, engineers working on SDV today, are actually graying their hair and getting older faster than they should, right? Because it's not a trivial problem. There is a big change. I think Ramanand mentioned it. It's a mindset change. It's a very big change for our industry. Now, if we unpack that a little bit, what really does that mean? Now, in the good old day, when we were building a car, every function in the ECU was, every function in the car was one electronic control unit, right? I want body features, let me put a body control. I want something to do with comfort and handling, there you go. I want increased power for, let's say my exhaust, something in my powertrain. I add a sister processor and so on and so forth, right? Now this is simply not sustainable anymore. That's one reason why we are moving to newer architectures. The second, of course, is the advancements that we have made when it comes to computing. Right? Today we have SoCs. I think there was a discussion earlier in the day about chiplets. Well, SoCs kind of combine microcontrollers, microprocessors, and give us a lot of compute that, like the rest of the world in the auto industry, wants to sort of adapt and use. So the first change or the first challenge is, how do we take these individual control units and sort of consolidate them to what we call today as zonals, or let's say HPCs, right? So first change in architecture. Certainly that's a challenge on how we achieve it. And, engineers are spending a lot of time to sort of do that. Second change, and this is a change as MathWorks where we are sort of very closely involved. What about all that software that you have been putting in your ECUs? How do you basically reuse them, consolidate them, and then put them on these newer SoCs, on these newer HPCs? That's probably the second challenge that the industry is, and the engineers are looking at. Now the third challenge is a very interesting one, right? Today when you sit in your, let's say the software-defined cars, you have these very fancy infotainment systems. Some of them are also running, let's say, some safety critical thing like, ADAS functionality maybe. So how do you basically architect the software to have a mixed criticality, right? I mean, infotainment is a fun to have comfort feature that may not be very safety and real-time critical. But on the same ECU, if you're running also a safety critical feature like ADAS, as a software architect, as a software implementer, you have a lot of things to consider, right? So this is the third challenge. How are you going to re-architect partition the software, deploy it on, let's say, the right real time with the right latency and so on, right? So this is the third sort of challenge that engineers are working on as we move towards software defined. And then there are other challenges like cybersecurity, looking at the thermals, changing the way you develop software from vCycle to CI/CD based, so that you can constantly update these and so on and so forth, right? So these are some of the challenges that we see as MathWorks as we are helping customers to sort of move from a traditional single ECU based to a more consolidated architecture based system, right? I'm going to take 30 seconds more, Murli, because as engineers, we don't just like challenges, right? We like to hear a little bit about what we can do as solutions. So something, and I'm speaking to the tooling community here and not really pitch in MathWorks, but as a tooling community, we have Brahma, Vector as well, my co-panelist as well. What is the tooling community helping you to do, right? We are investing heavily in helping you to evolve these architectures, simulate these architectures so that you can find the issues much before you actually go down to implementation. We are also investing heavily in helping you to architect software, something that the auto industry is still learning to do, right? I mean, we've not been the best at adopting, let's say, standards like SysML. Our aerospace counterparts engineers are far better at this. So we're learning how to basically architect software better, because that becomes very important, as I explained before. We're helping you to take the tools from a desktop, V-based environment to a cloud-based environment, so that you can keep updating your software and make your car, younger by the day. And I think we had a fantastic presentation from Stellantis. Of course, the need of the day is how you can integrate AI. Any tool maker, any tool partner today would not be doing their job if we are not looking at AI. How can we help you deploy AI on the ECUs, which is very tricky, by the way, to get the code that can sit on memory-constrained real-time ECUs? How can we give you co-pilots, right, that can make it, the development easier? And hopefully you're in that 15% of the engineers that Arvind spoke about. So yeah, to kick off this, I think those are my inputs, Murli. They are some of the challenges and what we are seeing in the industry.
Thank you, Rashmi. You talked about re-architecture of the system, and you also mentioned about infotainment as one, and then the safety critical, which is now, I think, do you mean to say that both should be in different containers, so that the engineers can develop depending upon the safety criticality of systems? Yep.
So I'll very quickly answer that. So my co-panelists, I'm sure Basavaraj can chime in as well. Yeah, so exactly. So basically these SoCs have, a good old microcontrollers, which are real-time, deterministic, run middleware stacks like AutoSAR Classic. So your safety critical ADAS will basically sit on that, right? And then you also want to then look at the microprocessor part of the SoC, where you can have more heavy compute like your infotainment features residing on that. And today the challenge, or today, let's say, the engineering work for us is how do you basically deploy these, make them communicate, achieve your safety criticality, as well as, let's say, the comfort and the updatable features that you want to do in your other domains like body infotainment and so on. So Raj, would you like to add?
Hello. Yeah. Vector is here to solve such issues. How do we mix? How do we build the platform across the ECUs and within the SoC? As Rashmi mentioned, we have this. In HPC, we are combining multiple ECUs, multiple applications, all coming together in one chip. Since they are mixed critical, that means some are SLD, some are SLP, we want tail operation, some are QM. So how do I work? If I mix them, then it is a risk for safety. So we have a system platform architecture design which is more modular, scalable, and can adapt such diverse domains in one. For example, we can have hypervisor built on a microprocessor and multiple different OSs with ASIL classification, and ADAS, IVI, vehicle functions can run separately, even if some of the applications are mixed in one ECU. So AutoSAR defines the way how to mix different safety relevant applications, platform, driver, and we call it as a partitioning concept.
Okay.
So all the solutions are possible from technology point of view.
Thank you. From the vehicle manufacturer's point of view, I would like to know from Mahesh, sir, the challenges that you face, especially in the zonal versus centralized, versus domain-based architecture. Because though you get support from the tier ones and the new companies like IT and software-related companies, simulation companies, etc., but it is the owners of the vehicle manufacturers to just create a layout which is suitable for upgrading in future. You can throw more light on this.
Yes, sure, Murrali. Thank you. Pleasure being here. So just before I could answer this, I think if you look at the evolution of vehicle architecture, probably 80s and 90s, we had ECUs for doing a specific function, and like ABS has one, airbag, infotainment, and so on. And then we started increasing the number of features, and probably by 2000s, our premier or luxury cars started having close to 100 or probably more than 100 ECUs, and it worked. And but then what it led us was spaghetti wiring and probably a lot of integration challenges, and this is why people started looking for beyond the domain based architectures, and some of them also looked at centralized architectures like Teslas and likes of them. And then over the time, I think even centralized probably is not the right answer. So because of the safety criticality involved and a single risk, because it's a single compute that they have there. I think as industry started thinking beyond the centralized and domain architectures, they started looking at, if we can have these controllers close to where the sensors and actuators are. And that's how the evolution of, zonal based architecture started. Probably even still in the early phases, each of these OEMs have their own definitions of what SDV is, and probably that definition will get standardized over the time. And if you look at even zonal based ones, it does provide good advantage in terms of having good time responses, time synchronization between different sensors that we have around. And then but it also comes with its own challenges, like for example all these different zonals will have middleware challenges to communicate with each other, and then even to have synchronization between them, and probably even the security challenges around that. So those are some of my inputs on what might be the challenges around the zone.
Interesting, Mahesh. But from the point of view of failure, addressing failures or the advantages of zonal computing versus the conventional, when it comes to addressing failures and also identifying them or probably minimizing failures.
If you look at the zonal architecture, so the sort of advantages or what it actually provides you is that the remote I/O, basically the number of I/O devices that you can connect to, you don't probably need a controller that has a stack there. It could just be, I think some of the panelists mentioned this during the initial conversation, that they can be just the dumb zonals which are just doing the I/O aggregation, send it to the central compute. And this reduces the amount of different stacks that we carry in the vehicle architecture, and probably the reusability which Rashmi also was mentioning about, so which becomes easier for ECU updations and things like that. So these are some things that probably which domain based architectures may probably not provide that much.
Yeah, when the systems get more complicated, I think the role of middleware is going to be even more stringent, and companies, there are a lot of companies developing their own. Basavaraj, I'm coming to you. Can you elaborate on the role of middleware in the cross-domain communication?
Yeah, sure, I can update that. To really address this middleware topic, I just want to go back 20-25 years back when I started development software. So I started with a simple basic engine system. There was no middleware. Yeah, like tier 1 was fully responsible. I write drivers, I write applications. Sometimes application also access the direct hardware, peripheral, and OEMs want to define new functions, new features. They want to introduce their software into the ECU. Then it's a heavy challenge integrating. Yeah, the application, different components. What is the interface? So then comes the AutoSAR. We call it as AutoSAR Classic. I call it as a static middleware. So they define the RTE, runtime environment, where it is possible to integrate different applications developed by different suppliers, as well as that there is defined interface between the modules. There is a well-defined BSW architecture, so the integration efforts become much easier. So I can speed up the timeline of the development. So I also worked in the infotainment, wherein the dynamic middleware came into picture first time, which is service-oriented communication, not the signal-oriented. So I used to work on a CSFW, which is a middleware which is proprietary inside Bosch. Later on, there were other middlewares where other different companies developed. Now Android is one of the famous middleware used in IVI. There are also different middlewares developed by, say, NVIDIA or Qualcomm or even ROS. I can see here there is some stall here, so that is also quite a good kind of middleware for ADAS and autonomous driving. So there is a lot of heterogeneous things coming into the vehicle. I never imagined that such ROS and Android would come into the vehicle at that time. Now we see everything happening. Mobile and all those technologies coming into the vehicle, and we have to live with it. But then this service layer, what I call it as application abstraction to make the hardware independent, needs a well-defined interfaces, data types, APIs, so that I can port application across. But that is a very future level, maybe in the next 5 to 10 years. But currently we have to live with this different heterogeneous middleware. But how to connect them? Yeah, in the vehicle there are different protocols, different ECUs. For example, even in static-based communication, I have CAN as a physical layer, LIN. Now Ethernet is coming into picture, and there is a network layer, session layer, and so many layers in between before it reaches the application. So we have to adapt these signals data, pass through all the layers, reach out to those domains across different networks. It is not just simple one central computer, it is a set of hundreds of ECUs in the vehicle. So we need to have some gatewaying, routing across these, where the services are ported. For example, now the famous protocol would be some IP, typically used connecting different domains in the vehicle, which is also pushed by adaptive AutoSAR. Some also talk of DDS, which is the backbone of the ROS to be the backbone, but we see it is a little bit high and more runtime consuming and might not be suitable fully for autonomous, but I feel that it will still be useful for autonomous driving, where it can best communicate with the infrastructure. So typically best suited for ADAS domain. But to connect it across the domain, some IP would be good, and additional gateways to connect to the remote ECUs.
Okay. Middleware used to be a few years ago developed by select companies, like for example Electrobit and many people, a few. But over a period of time, where ever since they thought about SDVs coming in, a lot of software companies also jumped into the bandwagon. So my question is whether is that particular aspect is being democratized for the advantage or disadvantage of the OEMs or tier ones?
Yeah, as I told, middlewares are there to standardize, so that my heterogeneous application, different parts can coexist and seamlessly integrate. Regarding the Electrobit, I think there is no middleware there. So it was mainly the HMI tool designed the HMI, but middlewares are different. But there is no standard industry body to define, especially in the SDV context. So with the classic AutoSAR context, some of the issues I can say RT is standardized, but some people are pro, some people are against. The people want to move toward open source, but what becomes standard there is not clear. In the SDV structure, when it comes to HPC, as I told, there are different middlewares. And now OEMs have a struggle, how do I combine, develop applications and port across. If I develop application in Android, it has to run Android. I cannot run in other. So we are coming up with something called as application framework. We are also contributing it, have made it as open source in the Eclipse SDV forum. so that other people can contribute and people can independently develop applications using the standard defined interfaces which are open sourced, and we can have the connectors or adapters to different middlewares. So that is a possible way to go, I see. Okay. It is kind of open source, and also if more community participates, then it would be a standard.
Thank you. Sudhakar, can you share your thoughts about the middleware, whether it is helping the OEMs or the tier ones in a way it's being democratized?
Yeah, so I'll first of all thank you for having me here. I would start with the recent announcement about Escort, where multiple OEMs are coming together and basically attempting to open source the middleware. The reason why that is a significant step is you have standards in the middleware, but then the performance differs. You are in a network where efficiency, speed matters, and when OEMs tend to bring these middlewares together, they are basically bringing in inefficiencies from the different software stacks that they have, and that brings big onus on having middlewares which are standardized, which are open source as much as possible, and that's where the OEMs are tending towards that direction. The other aspect is also when we look at the E architecture, which is nodes connected over a network, software also plays an important role. We have now Ethernet as a de facto standard on that. Some IP is built. Ethernet offers you speed, but it's also jittery. For the needs of an automotive network, it's still considered to be jittery. And if your software stack is inefficient, no matter how much bandwidth you add, that still would cause delays that you would eventually see as a functional performance. So it's important that software plays a significant role in the definition of the EE architectures going forward. One trend that we see is that not all OEMs, in fact, when we look at the market share, zonal computes is going to be the leading contributor to the market, whereas central computes are going to see a lesser contribution. The reason is central compute sounds nice and fancy, but then with it comes redundancy. How do you manage one compute having all the resources? What about thermal management? How do you manage that? And so on. So it's a case of software defining the future architecture, as you rightly put, rather than the other way around.
Okay, thank you. Can you throw a little more light on the challenges in designing for scalability and future upgrades in SDVs?
So I'll start with the challenges. Now, when we look at what we have been doing in the last decade, we have been building software primarily embedded and AutoSAR in nature. Now we are looking at probably tens of millions, even hundreds of millions of lines of code which has to be refactored, and then it has to be integrated onto this so-called zones and control central computes, and that is a challenge. The architecture would be there, and the second is we are currently looking at a scalability from perspective that internet technologies can have a 40% or a 50% headroom, but when you are talking about a car, how much of a headroom will still leave you some profit on the table? So it's important that OEMs play this delicate game, and they are designing systems which are scalable, because the features which are sold today can be activated for further performance. For example, Tesla now activates a drive mode which you can buy for $10,000 FPD. So OEMs have this delicate balance. Another aspect that I would like to bring is we look at architecture and its efficiency, but OEMs today are even looking at chiplets where they optimize the IP itself, because they would not want to have some of the electronic components which they would probably not use. And at the same time, it offers efficiency in terms of performance, and that trickles down into the network architecture.
Great, thank you. One more question to you, Sudhakar. Tata Technologies has recently launched a battery passport, in the US. I think BMW is your first customer. Do you see the possibilities of the entire vehicle getting a vehicle passport in the era of software-defined vehicle, because there are a lot of software inside, millions and millions or trillions of codes.
Yeah, that's a good question, and thanks for asking. Why did we target the battery first? Is because today, as we speak, the batteries manufacturing is one part, but then the way they are disposed is a significant threat to the environment and to a sustainable future. And for that reason, we had prioritized batteries to be prime candidate for tracking from, let's say, manufacturing all the way till their disposal. But at the same time, we also see that if you look at the products that likes of Apple and others make, most of it is reusable. Yeah. So we are going to see a trend where the car lives its maximum life, but we are also going to see a reusability of the raw materials which have been used on the car, plus the features which have been in the car are also transferred to the new car. So we are going to see a concept like a battery passport also applied to car, probably a car passport. Yeah, that's going to happen, but probably it will happen in stages, not at a single instance. On software side, you already have this. On software, you have the SBOM, which tracks software from its start till the end, including upgrades. Software is a different animal. For hardware, you would need to handle it in parts.
Great. But though they may have passports, vehicles may not need visa to travel abroad, right?
Yeah, passport is an identity that the battery carries with itself, with an expiry date.
With an expiry date. Okay. So, Mahesh, I would like to ask you about the OEMs. The SDVs give a new revenue stream for OEMs. So, what have you done any study like would the customer be willing to pay for a subscription or anything for the facilities or the features that he has already paid for the initial days?
I think there have been some studies done, but I think it's still evolving because I would still say that we don't have a full SDV in the market that offers subscription-based services. For example, in countries where, in cold countries especially, let's say you want a heating feature, and that's already there in the seats, right? So this is something that they can subscribe for a few months of the winter season, and probably maybe a massage feature or maybe a similar to Netflix, like an infotainment pack or something like that for the summer or so. So there has been use cases that have been put across. I think the rollout of it is going to be not so easy. I think it's going to be pretty similar to how our smartphones evolved from a keyboard sort of a keypad sort of a mobile phones to smartphones, and then later to digital transformations. I think our vehicles are also getting to digital transformations. I think as we talk, and probably in the next months or years, I think we should see the first ones probably offering basic features to start with, and then slowly incrementing as we did in the domain based, adding one ECU at a time which caters a specific feature. I think SDB will follow through the same incremental approach.
Subscription-based model will support, whether it will support the OEMs, or it will benefit the OEMs, or it will benefit the end customer. Because as a customer, I pay for everything, and then I pay a subscription. But front cost is on me.
A very good question. I mean, a lot of people keep asking this question. I just want to draw an analogy with the smartphone. If you look at the 90s and probably the early 2000s, we used to have only probably Nokia and a few other which used to operate their own operating system, and the app ecosystem was very weak or probably only monopolized with them. And over the time, as we saw, the reason for this is probably most of the OEMs thought it needs a lot of capital investment in terms of actually entering mobile phone business. But as you scale the hardware, especially if you get on a bigger scale, like the economics of scale, if you get the hardware and probably build an ecosystem where free open source, which Sudhakar was mentioning, where people started making apps in Google and Android caught up that particular thing, and then we started having probably smartphones that can just take Android any basic version, and then you can make use of the app ecosystem as much as possible. And I think if you draw that parallel with SDV vehicles, it is going to be initially a sort of a jump that needs where you would have probably low, mid, or high variants, not having too many variants as we have today in the Indian market, especially. We have cars where within 1 lakh difference from 15 to 25 lakhs, and then with the sunroof, without the sunroof, and so on, and things like that. But probably in SDV, we might have to rethink on how we position ourselves on, especially the hardware, because once the hardware is there, and probably the software is about over-the-air updates, and get the specific subscription-based as much as possible. So it's going to benefit the customer as well on a long run, and it is also going to be lucrative for the OEMs because as they achieve the economies of scale, I think it's a very good revenue model for both.
Thank you. Thank you. It was good inputs. Now I'd like to move a little bit. Software-defined vehicle, is it segment agnostic? The value proposition varies, from cars to commercial vehicles, even two-wheelers, even off-road. So, what is your view? And then, where do you see? Obviously, the cars will be the first one to become software-defined. But Rashmi, if you can just start by giving your views on which segment will be the first one, which is obvious. Of course, you can throw more light on this, and then the benefits for each segment.
Thanks, Murli. That's an interesting question. Probably my Mahesh from JLR is better suited to answer this, but I'll try to answer this from my industry observation and sort of what I'm seeing. Right? I mean, do all of us want to own a Tesla? Of course. Right? Do all of us want to pay for as much as a Tesla costs? Probably not. So I think, as an industry, I don't think everyone should aspire to become a Tesla, right? I mean, we should probably look at in passenger cars the mass market and look at what kind of software features are important for a value buyer, right? Which is actually the most of India, right? Maruti is still 44% of Indian market. So what do they care about? Do they care about heated seats and auto retracting sunroofs, and do they care about automatic wipers when it rains? Probably yes, but they're probably not willing to pay for it. So that segment will see the software defined as a very different sort of a value driver, right? And what we are seeing is for mass market, the SDV, and I think Mahesh said that different OEMs have different interpretation of SDV. For them, they are looking at, hey, how can I consolidate like 5 ECUs into one? Save on development cost with my vendors, save on harness, save my bill of materials, and develop a better a car with a better value proposition, right? So that could be their take on SDV. And then we have the mid-segment buyer, which is today in India probably 15 to 25 lakhs, right? I mean, they are looking at more software features, looking at more personalization. And that's a very interesting segment. It's an aspirational India. They're willing to pay more money, and those will look at I think body comfort, of course safety, how to provide those via software features and personalizations. And then of course we have the very premium segment where we will see, I think, the full-blown SUV as we see it, right? I mean, we will see NVIDIA GPUs, the best of comfort features, the best of ADAS features, and so on. Because yes, I mean, the aspirer of those cars wants to see those features and is willing to pay for those features. So that's my take on that. And then we have the commercial vehicle, which is very extremely economics and value driven. So SDV for them may mean, how let's say does the data come from the fleets how do you dashboard that? How do you look at driver behavior, and then you're able to send back, let's say, information to the fleet owner, or warn the driver, or attach that, let's say, to an insurance use case. This is the way I think for them the value from software will be realized. So quick sort of summary to your question, Murli, I think is software defined will mean very different things for different segments in the market. And I think we are going to see, as consumers, the best sort of menu offering there is, right, as competition increases. And I think as engineers, we need to learn to deal with more variants, to see how you can scale things that you have in one platform to other platforms, and so on and so forth. So that's my take on that.
Thank you. To Basavaraj and Sudhakar, see, if a car fails, you can rent a car and then probably you can continue with your work. But if a truck fails in the middle of the road, his revenue is affected. His income has gone. So because for him, the vehicle should roll always. So from this point, do you see SDV approach for commercial vehicle be more stringent than that of cars? You both can answer one by one.
See, this is irrelevant whether it is a SDV vehicle or not vehicle. If the car stops,
Speak louder.
Can you hear me?
Slightly better.
Yeah. So whether it is a SDV defined vehicle or a non-SDV, any vehicle, if car stops, loss is loss. Yeah. Irrespective how I develop the vehicle, the more you test, the levels of testing at each supplier, right from the simple component developer, ECU developer, HPC developer, we should have a well-defined verification and validation. Test setups, say shift left, virtual testing, then the physical testing, virtual cars or lab cars, hill systems. There are various levels of testing to validate before we put on the field. So I think that is primary important, irrespective. Maybe with the SDV there are different architecture, different electronics, different software. The way you test differs, but validation is more important to prevent. And right analysis. We call it as diagnostics. Can analyze it properly and how fast I can fix. For example, so with SDV, with old system we had this OBD tool, diagnostic tool. Someone has to go to the field, connect it, and I know what is the sensor, what is the failure, and then replace. But with SDV, the car is accessible directly via cloud, telematics. I can sit in some remote place and analyze, diagnose, okay, what has failed. I can send the engineer with that component to go replace it. It is very fast. I can also predict that some component can fail, and I have a preventive warning information to prevent such things.
Yeah.
Just to add to Basavaraj, fundamentally the commercial vehicles and passenger vehicles are different from the needs of the customer. One fact is that commercial vehicles were the first who had a significant need of connectivity and treatment, and that eventually trickled down to passenger vehicles, where we now expect our car to be always on, always connected, and so on. The software that goes on to a passenger vehicle as well as a commercial vehicle, probably from an architectural perspective might look similar, but the priorities are different. Yeah. For the commercial vehicle, you need fleet management, driver monitoring, driver analytics, connected feature, connected to the cloud, some level of monetization, maybe payment of toll via an automatic system, and so on. Whereas on the passenger vehicle side, you prioritize infotainment features, you prioritize ADAS and the customer user experience, and so on. So that's going to be the difference. But at the end of the day, as we are working with the industry and myself coming from the Tata brand, I can for sure with authority say that CV is not lagging behind. CV commercial vehicles have as much a stake in software-defined vehicles as passenger vehicles as well.
Okay, great, thank you. Mahesh, I would like to ask you about the scenario in the aftermarket.
when in the SDV era? From the passenger vehicle point of view, how do you see the aftermarket evolve in the SDV era?
It's an interesting question because I mean, see, if you look at, if you divide the passenger vehicle into at least two segments, like the luxury segment and the mass market segment, so you cannot have the same SDV in both the segments, because firstly, it's not going to be cost efficient for the OEMs as well, and probably it's a sort of a burden will also be passed on to the customers as well. So you can definitely say that SDV is not one size that fits all. So we have to be a bit careful on how what sort of features we're going to give it on the mass market segment, and because this segment is very sensitive about cost and how you actually get SDV rolled out there. Probably a variant of SDV. I'm not sure if the full SDV is at this juncture of time is really possible, can be rolled across both the segments. So if you look at the premium segment, the sort of customers are completely different. So they expect features that are that are sort of differentiation, like they want a personalized infotainment system or advanced driver assistance, more safety features and things like that. Whereas if you look at the mass market, most of the OEMs, if you look at, they're trying to see how we can find a price that a customer can buy, and it's going to take some time before we get there, where SDV is accessible to all segments, but it's going to be a phased out approach for that.
I would like to just go back to the battery passport thing. I believe the data from the battery passport will also be shared with the dealers. This is my understanding. Since you're working on SDVs, do you see the need to share data from an SDV with the dealer or the third-party multi-brand service centers who handle the majority of the cases?
Data sharing is a tricky topic. If you look at the regulations in the EU, GPDR and so on, and the regulation is also just around the corner in the Indian market. What happens is the data is shared, but then it is anonymized. You can't actually track it back to a particular vehicle or to a particular user. Of course, there was an incident with one of the European OEM where the data was leaked, but then generally speaking, we are talking about anonymization of data, and I see this to be a kind of like a give and take. Yeah? You are getting a car generally where you pay, let's say, 40,000 euros. You are getting that for 30,000 euros, where you are sharing data from the user. You are personalizing the experience. You are getting a feature custom made for yourself, which will be available as a software drop 6 months from now. So it's more of a balance again. But laws are, in the first session as we talked, it's also important to bring in the personal angle to it from a customer perspective. So we are going to see kind of a layer which abstracts user experience, user data sharing, and how OEMs or agencies will perceive that data. For example, if you are talking about an insurance case, which I asked as a question, if I'm driving the car, in that case you would need to know who the driver is as well, because I would get the points, I would be liable for payment. But when you are looking at a feature where how often do I use a heating feature in the car, then at that moment of time you don't require the user. So there is no one answer, but the fact of the matter is that we are going to see quite a lot of data which is going to open up, which will be shared with our dealers, with our OEMs, and at the same time that brings onus on the fact that the surface area that we have where things can go wrong, especially in the area of cybersecurity and so on, is also tremendous.
Great. Basavaraj, can I ask you to throw a little more light on the in-vehicle network? I think Mr. Raman, in the presentation Mr. Ramanand Patil gave, I could see the zonal computer, but again there are a lot of HPCs getting involved. Is there a possibility to optimize those in-vehicle network?
Yes, that is what the evolution is. So E-architectures are evolving. Earlier we had this function-oriented architecture, next it was domain-oriented architecture, now we have centralized and zonal-oriented architecture. So I think this is the segment which is most misunderstood in the SDV context. It means everyone is focusing on big HPC, everything I can do in HPC. No, there are a lot of other things like zonal, edge nodes, IO nodes. When I'm investing more in a HPC, it's also possible to optimize what I can do in the edge nodes. So that is also called as shift north. Yeah. Earlier, a lot of application logic, of course, there is a edge node, sensor, actuator, there is some control logic, but application was also executed directly there. So now OEMs are thinking, how can I optimize that? I am paying $5, $10, but can I make one that ECU or a small sensor in $1, $2, including software? Can I make a simple software where I don't have to invest too much? All OEMs specification, can it be pluggable? That is our proposition. So the cost of that IOS edges has to reduce or will reduce. And I also see a scenario, for example, if I move to pure SDV level 3 where Brahma present is level 1, level 2, level 3. So it's a misconception that it is purely a software defined vehicle. We assume that all hardware is the same, everything is available. But I want to propose hardware software co-designed vehicles. That means purely software enablement. I can install, if everything hardware is there, I can pre-install all the software. With some software switch, I can download and say, okay, this feature is available. The customer be ready to pay. The initial cost of the vehicle is also very high. Yeah, I try to buy a Tata Harrier, for example. There is only 3 segments: mid, low end, mid end, high end. For example, if I want a 360 camera, I have to buy high end segment where I have to pay for all the features which I don't want. Can I make these features pluggable? I want to buy a base variant, I can retrofit. For example, nowadays in the aftermarket, I can see people, okay, they also fit 360 camera. They put camera below this and also dash cam. Why can't OEMs enable that? Yeah, hardware, software, I want to buy it later. So this is possible through level 3 SDV. That means even IO edge nodes can have a Ethernet connection, or even if it is a physical connection, they can have a service-oriented communication and expose their service. For example, we have some simple light. Now we want to have a smart light in future. So it is already on the road. I want to replace that light with a new light system from the OEM itself, which fits into that ecosystem. Some kind of cybersecurity, threat protection, homologation, verification we can do, but I can enable such supplier to retrofit off-the-shelf pluggable software. That is the vision I see with the hardware software co-defined.
Thank you. Rashmi, I want a very short answer to a generic question. Taking a leaf out of what Mr. Arvind said, with AI, 85% of coding can be eliminated. So, what is the scenario in the industry now? You represent the industry, not your company.
The current scenario in the industry.
Yeah.
I don't think we are there yet, based on my observation. But AI is a very quickly emerging field, so it needs to be seen. I think what I can say that as technology providers, tooling partners, as MathWorks, we are investing heavily on the AI trend. We recently released the MATLAB Copilot. We are going to release the Simulink Copilot, coming 26A release. And there is enormous excitement, especially from the engineers in India, right? So I would wait to see whether that that scenario plays out. But what I can tell you is we're all working towards making training of the engineers, understanding of the code, doing error debugging, things like this, very simple. And then maybe in the foreseeable future, things like you have requirements, and then you already have, let's say, an algorithm, coming out of that without any dragging blocks and something like that. Code generation, of course, is another area that could benefit immensely from generative AI. What the future holds is hard to predict, but it's an exciting one.
Great.
Thanks,
Great.
Murrali.
Thank you. Thank you. Now I open the floor for questions from the audience. Due to paucity of time, we'll take 2 questions. Anyone? Yeah, please.
For you, currently the vehicle architecture is transforming from domain based to the zonal based, and the functions currently the comfort functions like the body functions, seat or the door functions are allocating to the zonal ECUs. So now the question is how the OEMs are looking for the time critical and safety critical functions like the airbag, braking system and engine ECU functions are allocating to zonal ECUs, and what are the challenges to face?
There in the HPC and centralized and zonal architecture, there are big HPCs where less time critical and moderately time critical applications are run in a microprocessor, but there are also microcontrollers in HPC which can run that. So there are also vehicles where there are no zonals at all, directly HPC and then IO control. There are also some OEMs where they control all the body control things in a zonal directly, but that puts a heavy load on the zonals, and also a lot of EMI, EMC, a lot of wiring directly connected to the sensor. So in the cloud architecture, we have something called as edge node. So edge node are IO sensors. So all the complex ECUs, which we are talking like battery management, engine control, radar, we call them the complex sensor IOs, but there could be simple IOs also. So they are not handled in the zonal. Zonal will act as a gateway or some body control mechanism to control the edge IOs. Or it can also be handled in the vehicle HPC. There could be ADAS HPC, infotainment HPC, but they can have a vehicle HPC which can control some of the non-critical powertrain functions and the body controls directly connecting to edge nodes. That is possible. So all categories are there. So it's a journey and a different OEM perspective how they define the vehicle and the steps how they migrate the architecture.
Any more questions? Yeah.
Hello, this is Halli Kere, Director of Architect Solutions, Bangalore. So, how effectively you can use software-defined vehicle in autonomous vehicle for driverless car for level 2, level 3, and level 4?
Maybe Mahesh, you can take.
All right, I'll give it a run. So, so if you look at, we've been talking about subscription-based features as such, right? So, assuming that we have the hardware that is necessary to subscribe it. So, if you look at driver assistance system, I may probably be driving in, let's say, a city, urban sort of a zone, and I want to have a AEB function or some sort of a lane keep assist or some sort of blind spot monitoring and all. So I probably could subscribe to those features when I am in a specific zone or a specific area, or maybe in a highway situation where lane keep might assist me for long driving hours or so. So and then even the sort of the over-the-air updates that you would need even to do a predictive maintenance for your vehicles and things like that. So all this will feed in to driver assistant to be specific more use cases that can actually also benefit.
Thank you. Thank you.
Just to add to that, Murali, just to add to that,
Yeah, please. Yeah.
one of the from an architectural perspective, let's say a tier 1 goes to an OEM and says ADAS, and when the OEM says I need L2, L2 plus, they would say, are you really sure? The reason is when you are going from an L2 plus, L2 or L3, L4, there is a significant change in the way the software architecture is derived. Also in terms of how it is assigned to the different application processors and so on. So it's also a design consideration which has to be taken care of. If the system is a L4, then you have a radically different way of looking at software architecture and hardware. compared to an L2 system?
Yeah, please. My name is Shashank Jaiswal. I represent a company in Dhruva. So my question is to Mahesh that there are two approach for SDV vehicle that is computer vision based or lidar based. There is always plus and minus point, but knowing all advantage and disadvantage, what is the OEM comfort? Because right now till Park Smart level 2 we can manage by anything, but the moment we go level 3 or level 4, there has to be very precise, the object detections and that brain of issue, everything need to be trained very advanced level. So all we know tech perspective, but as an OEM, I think I am taking this platform as a chance to hear the OEM perspective.
Interesting question. I think most of us keep facing that, but probably never have a full-fledged answer to it. So, I think most of the camera-based solutions that initially arrived, I think we understood that probably it lacks the depth to cover the, to really recognize the objects, and that's how we added more sensors to it, like radar, lidar, and so on. And probably even after all this sensors and sensor fusion among them, we still feel that there are incidents where it's still not fully safe as such, right? And we're still discovering different ways of actually providing safety, including GPS based way of also adding those information. So I think it's going to take some time and in fact even to process it. For example, if you look from SDV's perspective, I think one of the speakers was presenting the architecture where you don't have one high performance compute, you have multiple of them, because you may not, we could probably think of having one, but honestly speaking, camera itself provides very high bandwidth data, and you cannot compress them before you can send it to the center, because you would lose the time, and it's safety critical that you might probably lose on braking or some sort of specific critical decisions that you have to make. So I think we do not have, if you draw the parallel to somebody asking the question, if AI would replace the 85% of the coders, probably we are not yet there, and so would be the case for the ADAS section. And not yet there, probably there are some tidbits where still we need to get to that full, probably if not 100, at least more than 95% of safety.
Last question.
Maybe from my side. So can any one of you can show throw lights on the consortiums, the open source consortium? Because previously we used to have AutoSAR as a standard, it's commonly recognized and used by everyone. Whereas today there are lot many initiatives happening at different OEMs and tier ones, and everyone is confused like what is SDV. So now we have some consortiums, open source content consortiums, organizing it, making it as more in a structural way. So who is leading this work of creating a consortium, streamlining everything and creating a standard? So which would be the right choice for us to be a part of which consortium, so that it can help us to build a better products?
I'll initially take a stab at it, and maybe Basavaraj can add. As we covered in our discussion, the need for a consortia is ever greater. When we look at the latest trend, we see OEMs coming together along with middleware partners and vendors. That's the S-core. If I were you, I would track that closely. The second is the SOFI by ARM, which is also open sourcing the middleware, the orchestration part, and so on. We have the AutoSAR standards, which are ever improving anyway. We also have standards around communication. For example, you have COESA, which is standardizing the vehicle's signal specification. And these are some of the top consortia that I think of right now. But the direction that we are heading is open software, open platforms, right, rather than having closed systems.
So thank you, audience, for the questions. As we wrap this discussion, one thing is clear. Software-defined vehicles are not just about vehicles getting smarter, but also about redefining the entire experience of mobility. From safety to efficiency, from sustainability to personalization, SDVs are opening new doors to possibilities we once thought we belonged to only the future. Of course, challenges remain, whether it's technology, business models, or customer acceptance. But as we hear today, the direction is unmistakable. Vehicles will no longer be machines that age. They will be platforms that evolve. Thank you, panelists. Thank you, audience, for your. The journey will continue. SDV's journey will continue. Thank you so much.